Okay, so example number 1, we'll come back and finish graphing that after we talk about the transformations. So this is like any other function that we've done in transformation form. We have our a, h, and k. The equation is y equals a over x minus h plus k. And if you remember all our other formula or our other functions, k value makes the graph go up or down. Up if it's a plus sign, down if it's a minus sign. H makes it go left or right. And it's the opposite again. So left if it's a plus, and right if it's a minus sign. And then A can do 3 things. A can stretch the graph if it's greater than 1. It can compress the graph if it's less than 1. And it can reflect it if it's negative. So I'm just going to say reflect. Technically it's reflects over the x-axis, but in this case reflecting over the x is the same thing as reflecting over the y. So it reflects over the x-axis if a is less than 0. So that means it's negative. Okay, the h and the k value, depending on how it shifts, changes the domain, the range, and the asymptotes. So the h value changes the vertical asymptote. So instead of being at 0, x is now at whatever the opposite of this number is, so h. So if it's a minus, it's a plus. If it's a plus, it's a minus. And we say that the domain are all reals except this one value, x equals h. Another way you can say that, like on the previous pages, you can just say x cannot equal h. But this is how you would say it in words. It's all real numbers except that value. Okay, the horizontal asymptote is determined by the k. So whatever the k value is, that changes your horizontal, which is y equals. So in this case, y equals k. And that affects your range. So now we say the range are all real numbers except that value. Because remember, the asymptote is what it cannot be. It cannot be these numbers. So it's all possible numbers except this one value, which is k. Again, another way of saying that is just that y cannot equal k. But this is it in words. Alright, so on this page, all we're doing is taking this transformation form and we're plugging in a, h, and k. We'll talk about a little bit more in just a second. Right now, we're just going to say it's 1. Because these aren't being stretched or compressed yet. We're just looking at the h and the k. Right, so if we look at these functions right here, we're trying to make a rule, which is just an equation for them. So here, I want to make, again, all of these a's are 1, so 1 over x minus h plus k, 1 over x minus h plus k, 1 over x minus h plus k. So I'm looking for the h and the k. So the h is your vertical asymptote. So if I look at my graph here, my vertical asymptote is at 3. So vertical asymptote is x equals 3, which means I want the denominator to be the opposite. So if it's at positive 3, I want it to be at negative 3. And then the k value is your horizontal asymptote. That's this line right here, which is just the x-axis. So the horizontal asymptote is 0. So yes, you can come out here and go ahead and put plus 0. But that's technically the same thing as just not having anything. So I'm going to leave it like that. Okay, same thing over here. So we look for the vertical asymptote. This time the vertical is the y-axis. The y-axis is the line x equals 0. So that means the h value has to be 0. So this basically goes away. So nothing down there. And then the k value is the horizontal. So here the horizontal asymptote is at 1. So y equals 1, which means the k on the outside over here needs to be a plus 1. And then the last one, vertical, that dashed line is at -1. The vertical asymptote is -1, which means the h value has to be plus. So plus 1 here. And then we go to the k. The k is the horizontal at 2. Y equals 2. So then we put out here for k plus 2. So on all of these, like I said, all the a values were 1 because all of them had, from the middle for the center where the two asymptotes cross, you go up 1 over 1 to get here. Up 1 over 1. Up 1 over 1. And then down 1, -1, down 1, -1, down 1, -1 to get to these. They're always the same. Just one's positive, one's negative. If the a is not 1, well then you have to change the slope in quotations, not really slope, but of those first 2 points. Okay, so going back to this example number 1, using that slope idea. So here, this one has no h or k, so it's just 4 over x. So if it has no h or k, the vertical asymptote and the horizontal asymptote are 0, so the axes. So we want to draw our asymptotes. At 0, 0. Because the h is 0, the vertical asymptote's at 0. I'm going to draw the dashed line here for the, oops, that's not vertical. Dashed line here for the vertical. And there's no k, so y equals 0 is your horizontal. What's happening with the 4 is that's stretching the hyperbola out. So instead of being inwards right here at 1, 1, it's going to kind of stretch it out further. So I'm not going to do the table. I'm going to show you a little trick that allows you to get points without having to make the table this time. So here, the a value, we're going to treat it like a slope. So we're going to do rise over run. So 4 over 1. So again, like a slope is not really slope. So from the center, we're going to go rise 4, 1, 2, 3, 4 over 1 to get a point. Now because it's also called the reciprocal function, this one is also a point. So I rise 1 and go over 1, 2, 3, 4. So here's this piece of my hyperbola. It's going to be over here. And then to get the other side, because of symmetry, all I do is make these negative. So then it would be -4 over -1. So that means I go down 4, 1, 2, 3, 4, -1 to the left. And I can flip this one around as well. -1, -4. Down 1 over 1, 2, 3, 4 to the left. And I have that branch. So when you connect your dots, make sure you connect them with the curve shape that stays within the asymptotes. You don't want it to cross the dashed lines. Okay. And since these were both 0, now we can say that this domain is all reals except 0. And we can say that this one is all y's except 0. So you can write it in words, you can write it in symbols, it doesn't matter. Whichever one you choose to do. Okay, so one more that has you graph it entirely. Alright, so here we want to graph the asymptotes, and then we want to use the slope to find some other points. Alright, so looking at this one, actually let's describe the transformations first. The plus 2 makes it go up 2. The plus 3, it's opposite, so it makes it go left 3. And then I have the negative 1 as the a value, so the negative is going to make it reflect. So this time, the hyperbola, instead of it being in quadrants 1 and 3, it's going to switch to 2 and 4. So it's going to go the opposite ways. Okay, so remembering the vertical asymptote is the h value and the opposite here. So it's going to be the opposite of plus 3, which is negative 3. So I'm going to draw a vertical line at negative 3. Alright, and then the plus 2 on the outside, the k value determines the horizontal asymptote. So it's plus 2, and that one stays regular, so at 2. Horizontal's at 2. Okay, so instead of doing the table here, I'm actually just going to use the trick with the slope, with the a value. So here, since a is negative 1, I want to make that a fraction, so negative 1 over 1. So from here, I want to go negative 1, which is down, rise, so this is rise over run. So rise negative 1 means to go down 1, and then positive 1 to the right, so here. So now I want to flip these around. So now I have positive 1. Sorry, I should have wrote it over here, but I do positive 1 over negative 1, which means I rise 1 and go left. Now this time, because they're both 1s, if I make them negative, if I switch the signs, I'm going to get the exact same points. So these are the only 2 points I really can get from A. When it's a other number besides 1, I can get 4 points. But when it's just 1, I can only get 2. But we know that they're reciprocals as well. So I know if I go over 2 units, the reciprocal is a half. So I want to go down a half. If I go over 3 units, the reciprocal of 3 is a third. So I want to go down a third. And that's really as far as I'm going to go. If I go over a half, I go down 2. If I go over a third, I go down 3. You don't need this many points. You only need 2 points per branch. But it's the same idea. If I go over 4, I go down a fourth. If I go over 5, I go down a fifth. So here is this branch on this side. Again, keep it within the dashed lines. Same thing on this side. If I go over half, the reciprocal of half is 2. If I go over 2, the reciprocal of 2 is a half. And that's all I'm going to do here. You can do the third and the third if you want. But I only need 4 points total, and I have more than 4. So I'm good. Okay, really it's the h and the k that you need to be able to do all the time. The a value, sometimes I'll have you graph it, sometimes I just want to sketch and you match it up. Okay? Oh man. So following these next pages, they just want you to make an equation for the graph, or make an equation from the situation. The only one I want to look at is B. So we're trying to make a function in the form ax minus h plus k. So here it says, to produce the graph of a function, the graph of the parent function, 1 over x, has been vertically compressed by a factor of a half and shifted down 1. So let's do the down 1 part first. So if it's down 1, that's your k. So that means my k out here needs to be a minus 1. And since it's not being shifted left or right at all, that means h is going to be 0. So minus 0, which means you really don't even need a number down there. But I'm going to put it for now. Okay, so this compressed by a factor of a half. This is your a value. So that means a up here needs to be a half. The thing about that is we don't leave it, like you don't leave a fraction within a fraction. So there's a couple of ways you can do it, one better than the other. So here you can change it to a decimal, 0.5 over x, I'm just going to put x because I don't need the 0, minus 1. But even that is not very conventional because we usually don't keep a decimal within a fraction. So what we normally do is, if I have a fraction and a fraction, this ends up going to the bottom with the x. So if you see a number on the bottom in front of the x, that's actually a compression by this fraction. So I still have the minus 1. So this half is right here, 1 over 2. Not going to see it very often. We're not going to compress very often, but I just wanted to mention that because I think you see it on the homework. Right? And then again, your vertical is given by the h value. So in this case, h was 0. So the vertical asymptote is 0. And the horizontal asymptote is given by the k value. And the k value is negative 1. So y equals negative 1. Asymptotes, always, always, always make sure you write them in equation form, x equals y equals. Intercepts, which we'll get to in a second, we'll write as coordinates. Okay, that's it for that one.